In order to understand vector fields, we're going to look at some things that we have seen up to this point. For instance, the idea of a function. A function takes an element in the real numbers and maps it to an element in the real numbers. And we're used to this notation x mapping to f of x. X and f of x are both scalars, and it's actually more important for this discussion here that f of x is a scalar. And so we could say that we've seen what a scalar function is. We've also seen parameterized functions which map a point t, or a value t in the real numbers, into a point xy, which would be a point on a plane, or t could map to a point xyz, a point in space. Once again, in both of these cases, t would be an element of the real numbers. Adding to this list, we can consider a vector function, which takes in a real number, in this case I'll call it t, and maps it to a vector r of t, and this vector could be in either r2 or r3. So these are some things that we have seen up to this point, and we're going to see now what a vector field is. A vector field is a function that maps a point to a vector. Okay, so it takes in a point, xy or xyz, and maps it to a vector f of xy or f of xyz. That's a description. Let's look at a definition. Let D be a set in R2. A vector field on R2 is a function f with an arrow over it because it's a vector, that assigns to each point in D a two-dimensional vector f of xy. We can consider the three-dimensional analog of all of this by considering a set E in R3 and saying that it's a vector field in R3, and the points would be x, y, z in E, and it would be a three-dimensional vector field f of x, y, z. And depending on context, f can be a velocity field, a gravitational field, an electrical field, and or so on. And the gravitational field and electric fields are actually examples of force fields, because each of these is actually a force, right? So the distortion in space-time that a planet manifests is actually a gravitational field. It is a vector field. And we have a picture from the textbook here of a gravitational force field, and we can see that near the origin, so this would be the center of the object that's causing the gravitational field, the vectors are longer than they are out as you get further out, and that's because the force of gravity weakens as the distance between two objects increases. And also we see that the directions of all of these vectors, all of these arrows, are pointing towards the thing that is causing the gravitational force. Now let's look at an example of a vector field. We're going to sketch the vector field f of xy equals 1/2 xi plus yj. For each ordered pair x and y, we can compute a vector. And we'll do these for a few points: 1, 0, 1, 1, 1, 2. And so 1/2 of x is 1/2, y is 0. For the point 1, 1, we have the vector 1/2, 1. For the point 1, 2, we have the vector 1/2, 2. Let's plot these, or graph them rather. So the ordered pair 1, 0 has the vector 1/2, 0, maps to the vector 1/2, 0. The tail of the vector is the point of the input, right? So 1, 0, and we see that that's a short little vector pointing to the right. For the point 1, 1, the tail of the vector should be at the point 1, 1, and then the vector itself is 1/2, 1, and so points up toward the right. 1, 2 has its tail at 1, 2, and the x component is 1/2, the y component is 2, And so for each of these three vectors, the x component was the same, but the y component was increasing, and that's going to be characteristic of all the values that we have at 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, etc. Let's look at a few more inputs and outputs for this function, or this vector field. So I've written down a couple of more sets of inputs and outputs, and I'm only using the colors here so that it's a little bit clearer to see where these vectors are mapping to, where these points are mapping to. In practice, you would do them all monochrome. But it seems that the further out we get and the higher up we get, the vectors are getting longer, and the larger the y value, the larger the j component. This is a bit of a picture here of the vector field. Let's look at several more vectors in this vector field. Going back to monochrome here, I think this is enough to give you an idea of what the vector field looks like. And you can imagine this is very time consuming to do by hand. They're much better represented by computers.